Okay, what if every single shape in the universe, from a tiny atom all the way up to a galaxy, actually came with an energy bill? Today we're diving into a pretty radical idea called Leverian geometry. And it suggests that geometry isn't just about, describing space, it's an active energetic process where every line we draw has a very real consequence. This quote, man, it gets right to the heart of the matter. Leverian geometry kicks things off with a super bold claim that our entire mathematical foundation is built on this really convenient illusion, this idea that reality is perfectly smooth and totally frictionless. But what if it isn't? All right, so let's unpack that idea. What exactly is this illusion of smooth math? And more importantly, what's the hidden cost of treating our universe like it's some kind of perfect, frictionless abstraction? Okay, so think about it like this. In the math we all learned, imagining a perfect circle is, well, it's free. It doesn't cost anything, it's just a pure idea. But Leverian geometry comes along and asks this revolutionary question. What if, in the real universe, creating a boundary or just maintaining a distinct shape actually requires energy? What if abstraction itself has a kind of metabolic cost? And this brings us right to the Leverian solution. See, if abstraction has a cost, then geometry stops being just a passive description of space. It becomes something way more active, something like an energy account, where every single line and every shape has a price. This really captures the whole paradigm shift. On one side, you have classical math, which is kind of like a passive blueprint, just descriptions. But on the other side, Leverian math is active and thermodynamic. It basically argues that to even exist is to have a cost, and to be different from your surroundings requires a constant input of energy. It's a geometry with real-world consequences. So the stage where all this new math takes place is called Levar space. And here's the crucial part. This space isn't some empty, passive background. Oh no, it's an active participant. The sources even describe it as a breathing environment, a sort of flexible, dynamic fabric that actively helps regulate and maintain all the shapes that exist within it. So here it is, the core thesis. Every shape, every concept, every single distinction we make is really an entry in a universal energy ledger. In this view, geometry literally becomes the bookkeeping for reality itself. So if geometry is a form of energy accounting, we're going to need a new vocabulary, right? In this next section, we're going to break down the 4 foundational pillars of this new language: equality, inequality, equity, and inequity. Our goal here is to make these specialized, kind of tricky terms really, truly understandable. First up is equality, and let me tell you, this is a much stricter definition than the one we're used to. In this system, 2 things are truly equal only if the energy you would need to tell them apart is 0. And not just in one way, but across every possible metric you could imagine: size, temperature, information content, you name it. It's a state of perfect, frictionless resonance. There's a really great way to think about this that comes straight from the source material. Equality isn't just sameness. It's the universe achieving this moment of perfect, effortless equilibrium. It's the ultimate state of rest where absolutely no energy is being spent to maintain a difference. So if equality is a state of perfect rest, what is inequality? Well, here's the twist. It's not a flaw. In fact, it's the very measure of existence itself. See, to exist is to be different from everything else, and maintaining that difference costs energy. Inequality is basically the price tag of being you. This analogy just frames it perfectly. Think of it like your body's metabolism. You're constantly burning energy just to maintain your form, to stay alive and distinct from your environment, right? Well, in Leverian terms, that ongoing energy bill, that's your inequality. It's the cost of your coherence. Now we get to equity, and this is where the framework becomes profoundly structural. Equity is essentially a rule for stability. It says that for any system to be healthy and stable, it has to be a structural democracy. It has to respect all the different ways it can be measured, all of its various dimensions, without playing favorites. Here's a fantastic analogy to help you grasp this. Imagine a really complex system. It could be anything: a financial market, a living cell, as a 16-dimensional object. It has countless properties, way beyond what we can easily see. Well, equity demands that we account for all 16 of those dimensions. To only look at the 3 that we find convenient is to fundamentally misunderstand the object. So equity is the refusal to simplify reality just for our own convenience. And that leads us directly to our final pillar, inequity. So if equity is all about respecting complexity, inequity is the destructive act of forcing that complexity into a simple box. The sources use a powerful term for this: colonization. It's when an outside observer imposes their own simple grid on a rich, complex native reality. So, how does this destructive act actually happen? Let's go back to our complex, multidimensional object. In its native state, it's bursting with information, it's stable, it's coherent, it's a healthy system. Now, an outside observer comes along and performs what's called metric averaging. This just means they take all those rich, distinct dimensions and they collapse them down into a single, simple number, like an average score. But this is not a neutral act. The information from all those other dimensions is literally destroyed, not just hidden. And what you're left with is an unstable ghost of the original, a hollowed-out version that's lost all its structural integrity. This quote sums it up with incredible force. Inequity isn't just some mistake, it's a topological crime. In simple terms, that means it's an act that fundamentally breaks the structure of a thing. It prioritizes the observer's need for simplicity over the object's own nature, and it effectively destroys it in the process. So we've got these 4 pillars, but this isn't just some abstract theory session. In our final section, let's bring it all home. Why does a math with consequences actually matter in the real world? Let's just boil this all down to 4 key takeaways. First, existence has a cost. Being different requires energy. Second, simplification is not a neutral act. Forcing a complex reality into a simple box can actually destroy it. Third, true stability in any system, whether it's an ecosystem, a society, a particle, requires a democratic balance of all its parts. And finally, every single line we draw, every category we create, has a real thermodynamic consequence in the universe. Ultimately, the whole goal of Lavarian geometry is to shift our perspective. All of a sudden, mathematics is no longer this neutral tool for just describing the world from a safe distance. It becomes an ethical framework that forces us to be accountable for the consequences of the systems we design and the definitions we impose on reality. And just like that, we come full circle. This entire system is a rejection of that smooth lie that we talked about at the very beginning. It's a mathematics for a universe that isn't smooth, a universe where every dimension is a debt of coherence that must be paid, and every single active definition has a cost. This leaves us with a final and I think pretty provocative thought. If this framework is even remotely right, then every system we design, from a city plan to an AI algorithm, is an energy ledger. It forces us to ask, when we simplify things for our own convenience, what hidden costs are we creating? And for the complex, equitable world we claim we want, what price are we truly willing to pay for coherence?